Okay, so working on the review, problem number 9, the cosecant of 2 pi. I start this the same way. I figure out where 2 pi is. That's the point over here, right back at the beginning, 2 pi, which is 1 comma 0. Cosecant is the reciprocal of the sine. So I take the sine, which is 0, technically like 0 over 1, and I flip it 1 over 0. Anytime I have 0 in the denominator, it is undefined. So that is my answer for number 9. Number 11, I started in the same way. That's 1, 2, oops, I should be going backwards because it's negative 5 pi, sorry. 13, yep. So this would be 1, 2, 3, 4, 5 backwards, puts me on the axis on the other side. That's the point negative 1 comma 0, but this one I'm looking for sine. Sine is right there. Remember, it's cosine sine, so my answer here is 0. Done. I don't have to do any flipping. I don't have to do any stacking. I don't have to do anything fancy. Sine and cosine, the point gives it to me right away. Cosecant, secant, I have to do the reciprocal of one of them, depending which one I have. Cotangent, tangent, I have to stack them on top of each other, and again, it depends on the order. So for number 13, I have a cosecant of 3 pi over 2. So again, I figure out where that is, 3 pi over 2 down here. That's the point 0 comma negative 1. Cosecant is the reciprocal of the sine, so that's like negative 1 over 1. So I flip it, 1 over negative 1, or I just write that as negative 1. So reciprocal of the sine, flip it. Were there any other questions on the review that you wanted to see? Go ahead. 35, you bet. 35 is a graphing. Every time I graph, I start by remembering what the function looks like. And so cotangent is cosine over sine. So that means I'll graph the sine, the denominator, to find my asymptotes. And then I remember cotangent is the twist. So it twists starting up first and then twists down. So this is what the parent function for cotangent looks like. So now I have to put this all together. I have a phase shift to the left. I have a change in the way I number the axes, that theta axis or x-axis, because this is like 1/2 theta. So I'm giving myself room to shift to the left, and then I start with my 1, 2, 3, 4 tick marks. That last one is 2 pi over 1/2, or 4 pi. And then I number the rest of them by finding the quarter mark, the halfway mark, the 3/4 mark. Oops, that's just 3 pi. And now I'll figure out my phase shift. That's when theta over 2 plus pi over 4 equals 0. So theta over 2 equals negative pi over 4. Multiply by the 2 on both sides. And I move back pi over 2. So now I have to consider how I'm numbering this and figure out where back pi over 2 would be. This is back pi. So back pi over 2 would be right in between there, which means that I'm going to be working off of these tick marks. And because it gets super like messy in there, I always like to just find a different color to make that axis. So there we go, here and here, and so I'm going to only work off of, for me, the green marks. And I don't care about the numbers, I don't care about anything else. I'm just going to go ahead and graph that parent function. And so this is 4 and negative 4. I graph the sine to find my asymptotes, again, because sine is the denominator. So that's that little ghost graph that I do. So I make my asymptotes when the sine hits the green mark, and then from there, right in the center is where my twist is going to be, so it's going to come down and twist, and then come down and twist. And there would be my shifted graph. I know they get a little bit messy looking, and that's fine. Don't worry about the mess you make. I promise you. I can read what you do as long as, you know, it's like legible-ish numbers or whatever. I get it that it gets messy. Okay? Yes? 36. 36 is just a cosine graph. So this one is a nothing fancy on it. But I do have the shift with it again, another shift to the left, and another adjusted endpoint, so I'm going to give myself room. 1, 2, 3, 4. This last number is 2 pi over 1/4, because again, this is 1/4 theta, so that's 8 pi. Then I do the quarter mark, the halfway mark, and the 3/4 mark. There's no number in front, so I do 1 and -1 as my top out, bottom out. And now I figure out my shift. That's when theta over 4 plus 7 pi over 4 equals 0. So when theta over 4 equals -7 pi over 4. So when theta equals -7 pi, so this is a big shift. I'm going to multiply by 4, that'll cancel out the denominator. So it's 2, 4, 6, 8 backwards. That's why I always like to give myself enough room, plenty of room. Look at which way it's shifting. Give yourself plenty of room to work. My shift is going to be back 7 pi. And then I'll make my 1, 2, 3, 4 new tick marks that are all a little off. And I'll graph the cosine. Starts up, goes to the 0, goes to the low point at -1, back to 0, and back up to the top, or the high point. No denominator, nothing fancy, old school last chapter cosine. Okay? Anybody else, any other questions on the review? Anything else you'd want to look at, see, talk about before we... Yep. 47? Identity? So when you do the identities, again, especially when you're just getting started with them, my best recommendation is to rewrite it in terms of sine and cosine and work from there. So the secant squared is 1 over cosine squared, plus the next one is 1 over sine squared. And then I have 1 over cosine squared over sine squared. Those are x's. And now, again, I can do a couple of different things. There's not one exact right way to do this, but maybe I would get rid of this denominator over here on the right, and I can do that by multiplying it out. That's one way to do this. So that means I multiply it by sine squared on both sides. I have to multiply the whole thing. But over here on the right, it just totally cancels out. So now I have sine squared over cosine squared plus 1, because sine squared over sine squared would be 1, equals 1 over cosine squared. And so now, again, maybe I can take that step that I did here and multiply out the cosine squared. And I think that's the way I'm going to go with it. Instead of finding a common denominator, I'll multiply both sides by the cosine squared. Again, I'm going to have to distribute it throughout. Over on the right, that cancels out to 1. But on the left, it's going to be sine squared, because the cosine squared would cancel out the denominator. But then when I multiply by 1, it'd be plus cosine squared. And this is one of the identities I said it's very helpful to memorize or know. You'll get the sheet with it anyways. Sine squared plus cosine squared is 1, so I end up with 1 equals 1. And again, this is not the only way to do this by any means. It is a way. And so if you might have wanted to get common denominators here, you could have done that. I mean, there's so many multiple ways to do things. Just make sure it's legally math speaking, or legal math speaking, okay? Anybody, anything else? Yes? 22 and 40, yeah. (22) is when is the secant 1/2? And so the secant is 1/2 exactly when the cosine is 2, because they're reciprocals. But instead of me doing the reciprocal of this side, I prefer to do the reciprocal of the number side because that's easier for me to look at. And you can look all over the place, try as you might, think of all of the families, all of the points on the unit circle, everything we've talked about. The cosine is never 2, so this is a no solution. This will never happen. FYI, you will not get this on your test. I'm not going to mess with you that way on your test, but it can happen that it's just none of the points that we've dealt with. And so if you ever encounter that, that's how we deal with it. No solution. Okay? And then 40, another identity. And again, so many ways to start. When you're new, I would say put it in terms of sine and cosine just to get yourself started. So here, this is cosine over sine times cosine over sine minus 1 all over 1 over sine squared. On the other side, I'm going to distribute this through right away because I can. So I would write that as cosine squared x minus cosine x sine x. Good? Okay. And again, a lot of ways to go, but maybe I think I want to bring this, multiply that denominator out. I kind of like doing that because there's so many fractions going on. So if I multiply by the denominator 1 over sine squared x, it's going to cancel it off of this side, but I have to multiply it on the other side as well, and I'm going to have to distribute it throughout. So on the left, I still have cosine over sine times cosine over sine. And actually, if this was me doing this problem on my own, I might even distribute that part right away. You could. But over here, that leaves me with cosine over sine squared over sine squared when I multiply that, minus cosine over just sine, because the sine x on top is going to cancel out one of those signs on the bottom, okay? Which now I can see right away where this is going. So I'll distribute on the left, cosine squared over sine squared, multiply the numerator times the numerator, denominator times the denominator, minus cosine over sine equals exactly the same thing on the other side. Your goal is to get them to look the same, but keep in mind, if you did this problem on your own as a review and you got something that looked different in the end, it doesn't mean you're wrong. Just make sure they look the same. And that's why, like I said to you, I ask, you don't have to show every single step that you do, but make sense when you do it, because I know you can just get down to just write something equals something at the bottom, but that doesn't necessarily mean you followed a process, okay? So I do look closely at it, and if I can take a guess at what you were thinking, then you're all right, okay? All right, anything else? Anybody, any other questions? All right, then it is test time.